I feel like I'm a little bit of a late bloomer to science. When I was growing up, I enjoyed science activities, but I was interested in a lot of different things. I think mostly what motivated me was the ability to be able to help people. And so in my limited scope, I thought, well, why not? Why don't we become a doctor? It wasn't until I actually got to college and I started taking some science classes that I really started to be interested in what could happen if we could understand it at a deeper level. When I started my PhD, we were just investigating new physical phenomena of small structures. It wasn't a field. There wasn't a journal called Nano Letters or ACS Nano. All that came out much later. My group works on a range of projects. Primarily what we're focused on is being able to control matter over multiple length scales. One project in particular that we focused on is to make some of the world's smallest lasers. We designed nanoparticle arrays. Nanoparticles made of gold act like tiny little antennas. They can somehow capture large wavelengths of light and shrink it down and localize it to just on the surface of the particle. So we built arrays of these particles that can tightly confine light with tens of nanometers from the particle surface. And then we surround it with a gain material. And then you have light that excites the gain, which then transfers its energy to the cavity, in this case, these nanoparticle arrays, and then you get directional emission. This was a big deal because we could get directional emission at room temperature. And so the question is then, how do you make it tunable? This is a grand challenge in coherent light sources. We have these particles on a substrate, and then we surround it with our gain medium. This time, we make the gain medium a liquid instead of a solid. What that means is you can take the substrate, integrate it into a microfluidic channel, and then flow different solvent that with slightly different optical properties with the same cavity, and then you can get different colors depending on the solvent characteristics. So this is really neat because then you can, in real time, tune the lasing wavelength all the way across what the dye is able to do. I think an important question that everybody goes through in their life is, why do you do what you do? I mean, these small details can change throughout our lifetime as we have more experiences, as we fail, as we succeed. And so part of why I do what I do is to be of benefit to people. I want to boost them forward. I try to do this in almost any role that I play, whether it's in the university, whether I'm chairing a study section for the National Institutes of Health, whether I'm as an executive editor of ACS Photonics, where I work with editor-in-chief Harry Atwater to set vision and scope. Well, I want to elevate the level of everyone around me. I think that's really important.